Hey guys, this is for homework 9.2. So remember I told you guys in class today that for part 1 of this homework assignment, you only needed to answer question 1, which was just filling out that frequency table, that two-way table I should say. I know it says 1,000 two-way table, but we call it a 100 two-way table, just a different way of doing it. Okay, so this is part 2, and you're supposed to be following along with this video in order to answer the question. So if we look at the first example, it says, let's revisit a two-way frequency chart we saw in the last lesson. We just saw this as one of the questions that was on the back of today's handout. So it says, in this study, 52 graduating seniors were surveyed as to their post-graduation plans, and then the results were sorted by gender. So you can see the two-way table on here. And it says at the top, male and female, and total, and then along the side, going to college, not going to college, and total. So it says to let the following letters stand for the following events. M is male, F is female, C going to college, and not going to college. Then it asks, if a person was picked at random, find the probability that the person was first a female. Okay, so I'm going to look at just all females is 22. And then if it's just at random out of the whole lot of the people, then that would be 22 out of 52. Remember, you can reduce the fraction. You can write it as a decimal as well. Going to college, probability of going to college. Okay, well, total number of people going to college is 29, and that would be out of the whole, which is 52. Nothing new. So now part C. Here's where it gets new. Going to college, given they are a female, and the notation that you see there, P, C, and then it looks like a slash, F. It says draw a Venn diagram below to help justify the ratio that you give as the probability. Okay, well first let's just talk about this. Going to college, given that they are a female. So the probability we're finding is that they go to college. That's most important. But then it says given that they are a female. So we want to first look at how many females are going to college. So I see that's 13. And then we were only picking from the female category because it said given that they are a female. So the female category has a total of 22 people in it. Okay. We're going to eventually generalize how we did this. But the top we found from the females who go to college, so college and female. And the bottom was just the given information. So just all females. Okay, let's look. We didn't draw a Venn diagram, that's okay. So let's look at part D now. Part D says, which is more likely that a person picked at random will be going to college, given that they're a male, or will be a male given that they're going to college. So it sounds like maybe the same thing, but they are different. So let's take a look at how they're different. Okay, so probability that they will be going to college given that they're a male. Okay, if we relate this to the last problem we did, well on the top we did if they are going to college and a male. So going to college and a male would be going to college and a male would be 16. And then on the bottom for part C, we did just all the females because it said given that they're female. So on the bottom here it says given that they're male. So then we would do out of all the males. And all the males would be 30. Okay, let's compare it to the other one. The probability that they're a male given that they're going to college. So now the top, again, it would just be the intersection of where all males are going to college, so that's 16. But now the bottom is going to be different, because now the given, it said a person that will be a male given that they are going to college. So the given is that they're going to college, so that is what goes on the bottom. So all the people going to college would be 29. So here you can see the two probabilities are different. 16 out of 30 versus 16 out of 29. So it says which is more likely. Well, 16 out of 29 is more likely, or a higher number, bigger number than 16 out of 30. So it is more likely that Um, you are a male, given that you're going to college. Okay. We have one more question that we're going to do together. So this next question, example 2, let's take a look at. So this question says, in the generic Venn diagram shown to the right, they're not giving you a scenario, that's why it says generic. Each dot represents an equally likely outcome from a sample space. So they name the whole thing S as sample space. Some of these fall only into event A, some only fall in event B, some in both events, and some in neither. So you see there are dots that are not in bubble A or bubble B. That means they don't fall into either category. Consider the probability of A occurring given that B has occurred. So that's what this notation means. A given B. Probability that A occurs given that B occurs. Give a formula for the probability based on counting the number of elements in each set and their intersection. Okay, so the first thing we're going to do is let's look at the actual set. So the probability of A occurring given that B has occurred. Okay, so if B has occurred, then it's going to be out of all the elements in B. So I'm going to count all the elements in B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like there are 12 elements in B. And I counted everything in the B bubble. No, I lied. Let's back up for a second. I think it might be easier to generalize the formula first and then talk about it. Okay, so it says the probability, again, of A occurring given that B has occurred. So if you look back at the last two examples that we did, every time what we did is the top, or the numerator of the probability, was the probability of A and B occurring, divided by the probability of whatever that second number was. So if it's A given B, it's the probability of where it says given, so given B, that second number or letter. So this is always going to be your general formula, and what this is called is conditional probability, because it's giving us a condition that we have to follow. And this formula is super important. Conditional probability. The probability of A given B would be the probability of A and B divided by the probability of just B. Okay, I'm just going to do one more so that we are sure about this. Let's say the probability of X given Y. This should be the probability that X and Y occur divided by only the probability of Y, because we only divide by the probability of that second number there, or second letter, whatever we're describing the sets as. Okay, guys, we are not going to answer the second part of this example, which is part B. It's just not relevant to what we're learning. So that's all for now, and see you guys tomorrow.